Alright, hello Mr. Ito. My first presentation is going to be my chemistry class for fall of 2014. I got a pretty good grade in most of my finals and most of my units, but the one I'm most uncomfortable with is atomic theory and nuclear reactions. So I'm going to be discussing Unit 2A, and I'm going to be explaining these essential skills about the nucleus of the atom, the experimental basis for developing the model of the atom, neutrons and protons, and some of the properties of radiation. So for my first learning target, one of the most important things about the atom to note is that most of it is actually empty space, about 99% to be exact. What comprises most of the atom is the nucleus, which is composed of protons and neutrons. The reason that this makes up most of the mass, even though the atom itself or the radius of the atom will be much larger, is because protons and neutrons are very large. Electrons are a part of the atom as well, and a very important part, but they're so small that they don't contribute very much to the mass. For our next subject, the model of the atom, the final model that we most associate with atoms, was developed through a series of experiments. J.J. Thomson's experiment helped to develop the electron. What he did was he fired electricity through a series of atoms in a vacuum tube, which means that there were no particles in it whatsoever except for the atoms, and it produced small particles that could pass through a solid, which indicated that they were less than an entire atom. And when he exposed them to a positive charge, they were attracted, which indicates that they were negatively charged and small, and so they were named electrons. Ernest B. Rutherford helped to develop the nucleus by firing alpha particles through a gold foil. 99% of them went through, but 1% bounced back, which indicated that 99% was able to pass through it, while 1% was a dense center that wasn't able to go through the foil. And the properties of the nucleus were developed by both James Chadwick and J.J. Thomson. James Chadwick fired alpha particles at, I believe it was nitrogen, and this helped to develop the positively charged protons, and then J.J. Thomson fired alpha particles at beryllium, which helped to develop neutrons. They were both large, and so it was determined that these comprised the large cluster that stopped them from passing through the foil. Alright, next is the properties of the nuclear strong force and how it affects the nucleus. Protons, the electromagnetic law denotes that different charges would be attracted, so positive charge and negative charge of the proton and electron would be attracted together, and the positive charges of the protons would be repelled. Well, the nucleus is comprised only of positive protons and neutral neutrons, so one might think that the nucleus would spread apart due to the protons repelling each other. But the fact is that the nuclear strong force is much stronger than the electromagnetic force, so it overpowers any of the repulsion that protons have. Of course, if there are too many protons in a nucleus, or it's too large, it can become unstable, which leads me to my next topic of radiation. Radiation is when the nucleus of an atom changes due to it becoming unstable, and so what it will do, it will eventually lose mass and protons until it becomes a new atom, or it's just changed in some way. Radiation there are three types of rays of radiation. The heaviest radiation is alpha radiation, which actually has the same properties as helium, and what it does is it removes, it will take 4 away from the atom's mass and 2 protons from its nucleus, so it will actually change the element to a different one depending on how many protons you take away from the current element. Beta is the second heaviest, and it doesn't change the mass, but it does take away 1 proton, so it will change the element. And gamma is the strongest, and you need concrete and lead to block it, but it has no weight, and it doesn't really change the nucleus of the atom, but it does change the energy of the atom. So the mistakes in my final. Most of the questions I got incorrectly on the final were actually kind of small miscalculations. For this one, I just listed the number of neutrons instead of the number of protons, but I did know it, trust me. And this one, I didn't really understand the question, but after going over it a couple of times in the lesson, I understood what the question was asking, and I was able to know what I was supposed to be getting from it. And thank you for listening, and do you have any questions?
Awesome. We'll do questions after.
Okay. So, next I'll just... Alright, so this is going to be be my presentation for Integrated Math 2 in the first semester of fall 2014. Right. This is my chart for homework. As you can see, in the beginning I was doing pretty well on my homework checks and I was completing all of it. In the middle you can see a dip because I failed to complete some of my homework and my homework book wasn't very organized. So it registered as a low grade, which I completely understand, of course. And after that, I think I did recover. After that, we actually started working individual sheets of paper rather than moving in a notebook, and this kind of made it easier to organize for me. So it made it easier to submit my work and just kind of keep it together. For my assessments, I did have some trouble during my assessments. I did pretty well in the beginning. I always got a good score on my corrections because I do go back and I always try to find out what I got wrong, and I do try to fix it since I'm pretty spiteful when I get a question incorrect, so I do like to fix it. But the initial scores for the tests still aren't very good since sometimes after I correct something, I'll assume, okay, well, now I know it, I got it right, I'm going to get it right the next time, but that attitude actually leads me to get it wrong more than right. So, which leads me into my reflection. I think that in class I do pretty well because I try to ask any questions whenever I have a misunderstanding, and I do think I do take advantage of in-class work time. So most of the homework that was completed for the, I guess the later half of the semester was actually completed in class. I did like to complete my homework in class because I could ask for questions, and so I wouldn't have to do any emails or take any of my work home with me where I could lose it or something like that. I know I need to work on is my organization. It's been a problem for me for a long time. I think if my notebook was more organized, I would be able to keep track of my assignments. I would know when to turn them in, and I would know what to turn in, and I think that would change my homework grade a lot, as well as help me study for what I wanted to put in my notebook for quick reference. So I know that organization is something that now are my test corrections. So for my tests, one of the things that I find funny about this particular problem is that I had the same problem. I got it wrong for the same reasons in both the quiz and the test. So that kind of also let me know that I need to start really drilling myself on what I got wrong and not assuming that just because I corrected it, I'm going to get it right the next time. So in both of these, the issue was a miscalculation. So I did understand the equations, I substituted them correctly, and I was able to solve them. But I got more of a simple math wrong, so I also need to go back and I need to follow up on the basics that help me to solve the more complex problem. For this, it was still the same issue. One of the things I know I need to work on is simplifying square roots. I thought that I understood it during the lesson, but I do remember now I had some trouble completing the worksheets, just enough to finish it, but I didn't really have a full understanding, so now I need to know that I really need to go back and I need to make sure that I have a deep understanding of the concept so I can exercise it in quizzes and tests and make sure I get the entire problem correct. Now for my grade. The last time I checked, it was an A- at an 85. I do believe that this grade is appropriate. I'm a little upset that I'm not going to get, an A like I usually do, a 4.0, but I do understand the A-. I know that the A is correct because I did get most of my test questions correctly, and I did do fairly well on my quizzes, and I did my corrections, but I know that I do need to work on my organization. I know that the minus is mostly for the things that I didn't turn in, and I know that was on my part, but I do know that I have the potential to get a better grade, and I'm definitely going to work on that next semester. But overall, I think I did pretty well this unit. I just need to work on my study habits and my organization. This is actually one of the lowest grades I've ever had in math, so I know that one of my problems is I think that I know the content and the material, but I actually need to exercise it and make sure that I can apply it to quizzes and tests, so I think I get the grade I have the potential to get. And that's my PoL, and thank you for listening.